Between 1933 and 1945, the regime created protected facilities across Europe. During this period, hundreds of bunkers were built, along with thousands of defensive structures, numerous underground industrial sites, and dozens of disguised civilian buildings. In many cases, these locations were hidden in forests, carved into mountains, buried beneath government buildings, concealed in castles, and tucked inside ordinary city buildings. As a result, the construction needed thousands of tons of concrete. Major command bunkers had walls measuring 6 to 8 meters thick. Steel ran throughout every structure, steel that could have built tanks or ships. Air cleaning systems filtered all incoming air, while power generators supplied electricity whenever city power failed. In addition, large minefields surrounded remote facilities. Inside, blast doors weighing several tons sealed the entrances, and throughout the entire construction process, more than 1,000 workers lost their lives. Many of them concentration camp prisoners pushed to work until their bodies gave out. But what motivated Hitler to construct such an extensive network of hideouts? To answer that, we need to examine the different types of facilities that were built and the specific problems they were designed to solve. The categories range from command centers to underground factories to disguised urban offices. Each type served distinct functions within the regime's operations. Ultimately, the scale of this construction network reveals more about the regime's paranoia than its actual strength. Section 1. The Construction Network. The network is divided into distinct categories, serving different functions. Strategic hubs for decision-making housed senior leadership and provided spaces for major policy discussions affecting military operations and occupied territories. These facilities needed extensive communication systems, map rooms for tracking multiple fronts, conference spaces for large gatherings, and quarters allowing extended residence during critical periods. However, shelters built specifically for continuity of leadership during crises took different forms than command centers. These emphasized individual protection over operational capacity. Wall thickness increased beyond standard specifications. Also, air filtration improved to handle chemical or biological threats. Beyond that, emergency exits provided multiple escape routes. Security screening intensified for all personnel granted access. Leadership survival took absolute priority in facility design and resource allocation. Organization taught. SS construction offices and military engineering departments all worked on major projects, though through parallel and often competing chains of command rather than unified coordination, a dysfunction that wasted resources throughout the war. Initially, Organization Taught functioned as the primary civil and military engineering organization, responsible for major infrastructure projects including defenses, highways, and industrial facilities. Engineers within this organization developed standardized bunker designs, allowing rapid replication across multiple sites. They coordinated with massive labor forces, managed material procurement, and oversaw construction schedules. Franz W. Seidler's research reveals that Organization Taught coordinated hundreds of thousands of workers across multiple sites simultaneously, making this massive and ultimately wasteful building program possible. Without this level of organization, Germany could never have built so many facilities while fighting a multi-front war. This scale made it the largest construction entity within the regime's control. In contrast, SS projects often involved concentration camp prisoners as primary workforce, creating construction sites where unjust treatment resulted in thousands of casualties. The SS construction apparatus built facilities ranging from personal shelters for senior officials to elaborate complexes intended for ceremonial purposes unrelated to military necessity. Military engineering departments handled fortifications directly supporting combat operations. These units designed defensive positions, calculated fields of fire, positioned observation posts, and integrated individual bunkers into larger defensive systems. Military engineers understood tactical requirements better than civilian organizations, which influenced their designs. They prioritized practical military utility over symbolic impact or leadership comfort, though political pressure sometimes forced compromises where ideology overrode tactical sense. Because of this setup, competition between these organizations created inefficiencies as resources, labor, and authority overlapped. Different chains of command answered to different power centers within the regime. Rivalries among senior figures translated into competing construction priorities. Some projects proceeded despite questionable strategic value because they served factional interests within leadership circles. The resulting network showed strengths and weaknesses, reflecting this fragmented command structure where coordination depended more on personal relationships than institutional procedures. Financial costs are difficult to calculate, but records suggest billions spent while soldiers lacked ammunition and civilians faced starvation. In practice, budget allocation processes reflected these organizational competitions, with different agencies submitting funding requests to leadership figures who controlled resource distribution. Organization TOT requested funds for border defenses and infrastructure projects. SS construction offices sought allocations for their facilities serving security and ideological purposes. Military engineering departments needed resources for tactical defensive positions. In turn, leadership figures made allocation decisions based partly on legitimate strategic assessments and partly on political patronage favoring officials they personally trusted or owed favors. The budget process, therefore, combined rational planning with patronage systems characteristic of authoritarian regimes where personal loyalty mattered more than institutional competence. As a result, coordination failures resulted in duplicated efforts where multiple agencies built similar facilities in the same regions without knowledge of each other's activities. For example, urban areas sometimes contained multiple competing intelligence facilities operated by different organizations gathering similar information through redundant networks. Border regions received defensive installations from both military engineering and organization TOD programs without adequate coordination. However, the duplication wasted resources, but also created accidental redundancy that sometimes proved valuable when one organization's facilities were destroyed or captured, while parallel installations remained operational. Furthermore, disputes about who was in charge erupted regularly as different organizations claimed authority over the same territories or functions. For instance, SS construction offices and military engineering departments both built defensive works in border regions with unclear boundaries between their respective responsibilities. At the same time, organization TOT and private construction companies competed for contracts on major projects. On top of this, regional administrators clashed with central ministries about who controlled construction in their territories. These disputes consumed time and energy that could have been directed toward actual construction, creating delays and inefficiencies throughout the system. Personnel assignments reflected organizational politics as much as competence, with connections and factional loyalties influencing who received important project leadership positions. Overall, geographic spread reflected both strategic considerations and leadership preferences influencing site selection. For example, installations appeared in remote areas chosen for natural concealment and distance from enemy air bases. East Prussian forests offered thick tree cover and isolation from population centers. Mountain regions provided natural protection through elevation and difficult terrain. Border areas required defensive installations, creating obstacles for advancing forces. These remote sites followed military logic about defensive depth and protected command facilities. Florian M. Byerl's book, History of the Eagle's Nest, shows how planners struggled to keep facilities hidden while maintaining communication with frontline forces. This tension created design challenges that shaped how every major facility was built. Conversely, urban installations serve different purposes, requiring proximity to government, industry, and transportation infrastructure. For instance, major cities needed protected spaces for continuing civil administration during bombing campaigns. Communication centers coordinated multiple networks passing through urban hubs. Intelligence offices required access to populations under surveillance. Also, industrial facilities needed protected administrative spaces managing production schedules. Urban sites accepted vulnerability to bombing in exchange for access to resources and infrastructure concentrated in cities. Beyond domestic territory, the network extended beyond German borders into annexed territories and occupied areas under regime control. For example, facilities appeared throughout Austria after annexation in 1938. Czechoslovakia received installations following occupation. After that, Poland saw extensive construction after conquest. France hosted facilities in regions under direct administration. Belgium contained border defenses. Overall, each territorial expansion brought new construction projects establishing control and providing protected spaces for occupation authorities. As a result, the geographic scope grew with territorial conquest and contracted with military losses, creating a shifting network that expanded and collapsed following frontline movements. Temporally, chronological development shows how the system evolved from modest beginnings to desperate final efforts. Early installations between 1933 and 39 focused on basic government protection and border defenses. During this period, construction remained relatively modest with limited resource investment. At the time, confidence about Germany's position meant extensive fortifications seemed unnecessary. Standard government buildings with reinforced basements provided adequate protection for anticipated threats. During the middle period, construction from 1940 to 43 reflected growing fear as bombing campaigns intensified. More construction meant more desperation. Resource investment increased dramatically. Resources stolen from frontline troops. Wall thickness grew from meters to multiple meters. At the same time, underground spaces deepened beyond simple basements into purpose-built facilities, reaching significant depths. Meanwhile, labor forces expanded from thousands to tens of thousands at major sites. Standardized designs allowed rapid construction at multiple locations simultaneously. Overall, this period saw the most intense construction activity as Germany still controlled extensive territory and could access necessary resources. One category shows how thoroughly these facilities blended into everyday life, operating in plain sight while thousands walked past daily without suspicion. Later, final phase construction from 1943 to 45 showed desperation as Germany's situation collapsed. Projects became increasingly focused on immediate survival rather than long-term planning. For example, underground factories attempted to preserve industrial capacity after surface facilities were destroyed. Deepened command bunkers in Berlin prepared for siege conditions. At the same time, emergency shelters multiplied as cities faced sustained bombing. Despite this, construction continued even as resources grew scarce and front lines approached building sites. In fact, some projects remained incomplete when advancing Allied forces overran locations. Meanwhile, others finished just weeks before capture. In the end, the chronological pattern shows how construction of protected locations intensified precisely as territorial losses mounted and strategic circumstances deteriorated. Concurrently, material requirements strained Germany's economy as construction accelerated. Each major bunker consumed thousands of tons of concrete, requiring cement production, aggregate mining, and transportation to often remote sites. Steel reinforcement competed with armor plate production for tanks and ships. Specialized equipment like blast doors, ventilation systems, and generators required manufacturing capacity needed elsewhere. Fuel transported to construction sites could not simultaneously supply military units. Labor forces building bunkers were unavailable for weapons production or military service. As a result, the total resource diversion affected Germany's military capabilities measurably. Yet, leadership prioritized protective construction even when this weakened actual defensive strength. Workforce composition reflected regime priorities and available labor sources. German skilled workers handled specialized tasks requiring training: steel installation, electrical systems, precision concrete finishing, and equipment calibration. These workers received normal wages and worked under standard conditions. However, most heavy labor came from forced sources. Concentration camp prisoners provided the largest component of construction workforces at major projects. Prisoners of war supplemented camp labor at numerous sites. Civilians conscripted from occupied territories filled additional labor needs. This forced workforce faced brutal conditions: inadequate food, minimal shelter, and constant risk of violence. Thousands died during construction from exhaustion, starvation, industrial accidents, and deliberate mistreatment by guards. In the end, the protected facilities protecting leadership were built directly on systematic exploitation of people treated as disposable resources. The transition between planning and implementation involved multiple bureaucratic layers where competing priorities created friction. First, architectural offices prepared initial designs based on leadership requirements and site characteristics. Then, engineering departments reviewed plans for structural feasibility and calculated material requirements. After that, procurement offices identified sources for supplies and arranged transportation. Meanwhile, labor allocation offices assigned workers from available pools, including concentration camps. Finally, construction management coordinated the various elements, attempting to maintain schedules despite shortages, transportation problems, and interference from other agencies competing for the same resources. This complex bureaucracy sometimes worked efficiently, but often created delays when different offices disagreed about priorities or when higher authorities intervened with changed requirements. Albert Speer described in Inside the Third Reich how leadership preferences often overruled strategic sense, leading to facilities in questionable locations. This political interference helps explain why some facilities served symbolic purposes more than practical military needs. As a result, inspection procedures varied between facilities and evolved over time as construction experience revealed common problems. Initial inspections occurred during excavation to verify that foundation conditions matched what surveys predicted. After that, structural inspections monitored concrete curing, checking that proper strength developed before additional loads were applied. Reinforcement inspections verified that steel placement matched engineering specifications. Then, waterproofing inspections tested seals before backfilling. Mechanical system inspections confirmed that ventilation, power, and water systems functioned according to design parameters. Finally, final inspections assessed whether completed facilities met acceptance criteria before occupation. Documentation from these inspections created paper trails showing construction quality varied significantly between projects depending on available resources, workforce skill levels, and time pressures affecting different sites. Adaptation of existing structures presented different challenges than new construction, requiring engineers to work within constraints of buildings not originally designed for fortification. In fact, technical challenges varied depending on facility type and location. Excavating through solid rock required drilling equipment, explosive expertise, and debris removal systems. Deep foundations below water tables needed constant pumping to prevent flooding. Ventilation in sealed spaces demanded complex air circulation, preventing carbon dioxide buildup. Independent power required generators, fuel storage, and electrical distribution systems. Communication equipment needed protected cable routes and radio installations. In the end, each technical requirement added complexity, cost, and construction time to projects already strained by wartime conditions. Moreover, foundation engineering became increasingly complex as facilities grew larger and protection requirements intensified. Early bunkers used simple spread footings, distributing structural loads across wide areas. However, later facilities required deep foundations reaching through unstable surface soils to bedrock, capable of supporting massive concrete structures. In some instances, pile foundations drove supports deep underground where soil conditions made surface footings inadequate. In fact, some installations required foundation work extending 10 or more meters below final floor levels, creating subsurface structural systems as complex as the visible portions of buildings. Despite this, engineers conducting foundation work in wartime conditions lacked the extensive site investigation that peacetime projects would receive, sometimes discovering unexpected ground conditions requiring design modifications during construction. The network is divided into distinct categories, each revealing something important about how dictatorships put their own survival over everything else. Concrete formwork presented logistical challenges because pouring massive walls required temporary structures holding wet concrete until it cured sufficiently to support itself. Wooden forms built to shape and support concrete during curing represented significant material investments. Such large installations required thousands of board meters of lumber just for temporary formwork that would be removed and often reused at other locations. Shortages of suitable lumber sometimes forced construction delays while formwork materials were transported from other sites. The formwork also required skilled carpenters who understood how to build structures capable of withstanding pressures from wet concrete without collapsing or deforming. In fact, form failures during concrete pours created dangerous situations and required expensive repairs, removing defective concrete and starting sections over. In fact, concrete mixing and placement demanded careful quality control, maintaining proper proportions of cement, aggregate, sand, and water. Improper mixing ratios weakened finished structures, potentially creating vulnerabilities that might not become apparent until facilities faced actual attack. As a result, quality varied between projects and even between different sections of the same facility as material availability fluctuated and supervision intensity varied. Some installations used concrete of excellent quality, rivaling peacetime construction standards. However, others incorporated substandard materials when shortages forced compromises. Despite this, testing procedures attempted to verify concrete strength before structures entered service, but wartime pressures sometimes meant facilities were occupied before full strength developed, or despite test results indicating quality problems. Similarly, reinforcing steel installation required understanding of structural engineering principles, determining proper placement patterns and connection methods. Rebar frameworks created three-dimensional structures within concrete, providing tensile strength that concrete alone lacked. The steel had to be positioned accurately according to engineering plans, with proper spacing maintained throughout pour operations. Tying rebar together into rigid frameworks required substantial manual labor by workers who understood how to create strong connections. Thus, improper steel placement could critically weaken structures even if concrete quality remained high. Despite this, inspections attempted to verify correct installation before concrete was poured, but the complexity of dense reinforcement patterns sometimes meant errors went undetected until concrete encased the steel, making corrections impossible. Furthermore, waterproofing underground facilities required multiple layers of protection, preventing moisture infiltration that could undermine structural integrity and create unhealthy conditions for occupants. In response to surveillance threats, camouflage techniques evolved as aerial surveillance improved. Early efforts used simple methods like painting bunker roofs to match surrounding terrain or planting vegetation to blend structures into forests. However, more elaborate approaches built false surface structures above underground facilities, creating appearances of farms or industrial buildings while actual operations occurred hidden below. Excavation debris presented particular challenges because large spoil piles visible from aircraft betrayed construction activities. Because of this, engineers learned to spread removed earth thinly across wide areas rather than creating concentrated mounds. Night construction reduced daytime visibility. Forest canopy concealed activities occurring under thick tree cover. The investment in concealment sometimes rivaled the investment in actual protective construction. Beyond simple camouflage, natural terrain integration became complex art combining engineering capability with landscape design principles. Construction adapted to existing topography rather than completely reshaping terrain when this allowed better concealment. In many cases, buildings nestled into hillsides blended with natural slopes. Bunker roofs matched surrounding ground levels. Entrance structures mimicked natural rock formations or agricultural buildings typical of regions. In addition, roads followed existing paths where possible rather than creating obviously new routes. In the end, these integration techniques required additional planning time and sometimes complicated construction, but they improved concealment effectiveness significantly compared to structures that appeared obviously artificial in aerial photographs. Temporally, seasonal adaptation of construction schedules recognized that certain types of work proceeded better during specific weather conditions. Concrete pouring worked best during moderate temperatures, avoiding both freeze risks in winter and excessive heat in summer. Similarly, excavation in wet climates proceeded more efficiently during dry seasons when groundwater levels dropped. Transportation of heavy materials required frozen ground conditions in some northern regions, where spring thaws created impassable mud. As a result, construction planning therefore incorporated seasonal factors, though military urgency sometimes forced work during unfavorable conditions when strategic requirements outweighed weather considerations. Regarding the workforce, living conditions for workers varied dramatically between skilled German employees and forced laborers from camps. German workers received housing in proper barracks with heating, adequate food, medical care, and reasonable working hours. In contrast, forced laborers occupied crowded temporary structures with minimal protection from weather, received starvation rations, lacked medical attention, and worked exhausting hours under constant threat of violence. This stark differential treatment reflected regime priorities valuing German lives while regarding prisoners as disposable resources to be consumed during construction, regardless of survival rates. Finally, the contrast created two entirely different experiences of the same construction sites, depending on worker status within the regime's racial and political hierarchies. Tragically, worker mortality data remains incomplete because systematic records were not maintained for forced laborers whose deaths were considered administratively insignificant. German workers who died received proper documentation, death certificates, and notification of families. By contrast, forced laborers who died were sometimes simply noted as casualties in construction reports, or ignored entirely in official records. Meanwhile, mass graves near construction sites provide archaeological evidence of death tolls that written records do not capture. Survivor testimony fills some gaps, though memories from traumatic experiences cannot provide precise statistical data. The incomplete documentation itself shows how thoroughly the regime dehumanized forced workers, treating their deaths as unworthy of the basic record-keeping that marked other construction aspects. Organization Taut was the primary engineering group, yet its capabilities were constantly undermined by competing agencies refusing to coordinate. Security protocols protected construction sites and completed facilities from espionage and sabotage. Construction workers at many sites understood they built protective structures but lacked detailed knowledge about final purposes or future occupants. Similarly, contractors received specifications showing dimensions and structural requirements without explanatory context. This compartmentalization reduced how much any individual knew, but also created inefficiencies when workers could not understand how their tasks fit into larger projects. At the same time, security forces guarded construction perimeters, controlled access to restricted areas, and investigated any suspicious activities. Meanwhile, workers who caused problems or appeared unreliable faced harsh punishment or removal to concentration camps. In the end, the security apparatus surrounding construction created additional costs and complications, but remained essential given the strategic value of facilities being built. This foundation establishes the categories, organizations, geographic spread, and challenges that shape the protected facility network. However, understanding why this system developed requires examining the specific historical events and pressures that drove leadership toward isolation and fortification throughout the war years. Competition between groups created waste as resources, labor, and authority overlapped without clear chains of command to resolve disputes. Section 2. From Triumph to Terror. The political environment within German leadership encouraged private secure spaces through the internal rivalries that poisoned relationships at the highest levels. Competition for power among senior figures created suspicion and distrust extending even to close associates. To illustrate, party officials maneuvered against military commanders. SS leadership operated increasingly independently from regular government structures. Regional administrators clashed with central ministries. In addition, personal networks mattered more than institutional authority in many decisions. As a result, this atmosphere of mutual suspicion made leaders desire private refuges where they could operate without observation by rivals who might use information against them in political warfare for influence and resources. Peter Longerich documented how this SS rivalry with other agencies led to wasteful parallel building projects. Different groups used the same scarce materials and workers on competing facilities. Resources that could have strengthened actual defenses instead got spread across duplicate projects, serving factional interests rather than military needs. Indeed, Hitler's style of governance encouraged these rivalries by design rather than accident. He deliberately created overlapping authorities where multiple officials held responsibilities for similar functions, forcing them to compete for his approval. This competition prevented anyone from building up independent power bases that might threaten his supreme position. However, it also meant that coordination between different government branches often failed because officials refused to cooperate with rivals. Thus, protected facilities allowed individual leaders to maintain private spheres of control isolated from competitors. The resulting system resembled feudal power structures more than modern centralized government, with each major figure establishing personal domains, including secure headquarters serving as power bases. Militarily, defense strategies developed after rearmament programs began in the mid-1930s, reflecting Germany's departure from Versailles Treaty restrictions and renewed military development. The Versailles Treaty imposed after World War I severely limited Germany's military capabilities, restricting army size, prohibiting certain weapons, and demilitarizing border regions. By the mid-1930s, Germany openly violated these restrictions through rearmament programs, rebuilding military forces. Fortification construction formed part of this broader rearmament. The West Wall project along the French border began in 1936, employing hundreds of thousands of workers in what became the regime's first major defensive construction program. In the end, this massive project demonstrated organizational capacity while creating physical barriers, reinforcing diplomatic positions during negotiations with other powers. Early fortifications focused on border defense rather than leadership protection. The assumption held that future conflicts would resemble World War I, with relatively stable front lines and conventional warfare. As a result, protection meant defending German territory from invasion rather than sheltering leaders from specific assassination threats or strategic bombing. These early fortification concepts emphasized quantity over sophistication, building large numbers of relatively simple positions rather than smaller quantities of heavily protected structures. In addition, standard designs allowed rapid replication, but limited protection reflected threat assessments that would prove inadequate once warfare evolved beyond pre-war expectations. Tactically, construction methods for early fortifications drew on lessons from World War I trench warfare, but adapted them to modern requirements. Engineers designed bunkers with overlapping fields of fire, allowing defenders to support adjacent positions. At the same time, observation posts positioned to provide clear views across approaches gave early warning of attacks. Meanwhile, anti-tank obstacles channeled vehicle approaches into kill zones where defenders concentrated firepower. Minefields supplemented physical obstacles, creating multiple defensive layers. However, these fortifications showed understanding of defensive tactics, but reflected expectations about attack methods that technological developments would quickly render outdated. In fact, the rapid pace of military innovation during the late 1930s meant fortifications designed in 1936 were already becoming obsolete by 1939 when war began. Yet personnel training for bunker operations received less attention than construction itself, creating situations where excellent defensive positions were sometimes manned by inadequately prepared troops. Specialized bunker defense units understood defensive tactics and were familiar with the specific bunkers they occupied. Despite this, as the war progressed and casualties mounted, replacements often lacked this specialized training. Young conscripts who had never seen their assigned positions before arriving at the front struggled to use complex defensive installations effectively. As a result, this training deficit reduced the practical value of even well-designed fortifications when defenders could not fully exploit the advantages their positions provided. Beyond this, moreover, ammunition and supply requirements for sustained defensive operations were sometimes underestimated during planning phases. Fortified positions needed stockpiles supporting extended battles if supply lines were cut or disrupted. Still, planners calculated requirements based on expected combat intensities, but actual battles sometimes exceeded these assumptions. Defensive positions that ran out of ammunition became useless regardless of how strong their physical construction might be. Thus, supply issues therefore represented vulnerabilities that no amount of concrete could address, revealing limitations in defensive strategies that emphasized structural protection while underestimating logistical sustainability. Internationally, military observers studied German fortification efforts, drawing conclusions about intentions and capabilities that influenced their own nation's military preparations. Job assignments reflected politics as much as skill, with connections and loyalty mattering more than engineering ability or construction experience. International factors reshaped defense thinking as military technology advanced and international tensions increased. The Spanish Civil War between 1936 and 39 provided testing grounds for weapons and tactics that would appear in larger conflicts. This became evident during the aerial bombing of Spanish cities, particularly Guernica in 1937, which demonstrated the destructive potential of aircraft on urban centers. German forces participated in these attacks, gaining experience while also recognizing vulnerability to similar campaigns against German cities. As a result, observing destruction from the air influenced military planners, considering how to protect critical facilities from similar attacks. Specifically, Britain's rearmament accelerated through the late 1930s as the international situation deteriorated. The Royal Air Force expanded significantly, acquiring modern bombers with greater range and payload capacity than previous generation aircraft. Germany observed these developments through intelligence services and open sources, understanding that British air power would eventually threaten German territory if war occurred. In turn, this recognition drove decisions to strengthen protection for government facilities and military headquarters that might face aerial attack in future conflicts. The assumption that air power would play major roles in coming wars influenced construction priorities even before actual combat tested these theories. Richard Overy's analysis shows how sustained air raids created psychological shifts in how German leadership viewed their own safety and vulnerability. These psychological changes drove construction decisions that Germany's economic situation could barely support. In fact, as surveillance improved, increasing Allied monitoring required new concealment strategies to protect facilities from detection. Aircraft overflew border regions, photographing fortifications and industrial sites. Over time, aerial photography improved steadily, with better cameras and interpretation techniques revealing more detail about ground installations. Consequently, German planners understood that visible facilities would become bombing targets once conflicts began. This knowledge encouraged underground construction and complex camouflage, reducing chances of detection. The cat-and-mouse game between concealment efforts and aerial surveillance capabilities continued throughout the war, with each side adapting to the other's improvements in ongoing technological competition. Later, photographic interpretation became a specialized intelligence skill, with trained analysts examining aerial photographs for telltale signs of military installations. New construction left marks visible from the air, including excavation spoil piles, construction vehicle tracks, cleared areas, and fresh concrete appearing lighter in color than weathered surroundings. Because of this, interpreters learned to recognize these indicators, identifying facilities despite camouflage efforts. To counter this, German countermeasures evolved in response, using more complex concealment techniques and limiting construction activities to periods when poor weather prevented aerial surveillance. Ultimately, this competition drove continuous improvements in both photographic intelligence and camouflage technology. Additionally, radio direction finding allowed Allied intelligence to locate transmitters through triangulation using signals from multiple listening posts. German communication security required balancing operational needs for radio contact against risks that transmissions would reveal facility locations. To address this, strict radio discipline limited transmissions when possible. Mobile transmitters broadcast from locations away from actual command centers, creating false impressions about headquarters positions. Elaborate deception programs used dummy facilities with active radio stations, drawing attention away from genuine installations. Overall, these electronic warfare measures added complexity to communication operations while attempting to preserve operational security against increasingly capable enemy intelligence systems. Environmental factors also influenced both construction schedules and operational security, with seasonal variations affecting when work could proceed and when surveillance flights could detect activities. Operationally, pressures emerged as maintaining command and control systems became increasingly difficult, with front lines moving closer to Germany. Early war years saw rapid advances, creating extended front lines thousands of kilometers from command centers in Germany. To manage this, maintaining communication across such distances required reliable telegraph lines, radio networks, and courier systems connecting headquarters to field commanders. Initial successes in Poland, France, and early Soviet operations suggested these systems worked adequately. However, as the war continued and front lines stabilized or began contracting toward Germany, operational pressures mounted. In the east, Soviet resistance stiffened after initial German advances in 1941 failed to achieve knockout blows. Consequently, the front stabilized into grinding attrition warfare, consuming enormous resources while producing limited territorial gains. At the same time, German forces became overextended, with supply lines stretched thin and communication systems strained by distances involved. Eastern Front operations required constant communication between forward units and headquarters, making strategic decisions about resource allocation and operational priorities. Ultimately, the sheer scale of operations across thousands of kilometers of front created unprecedented coordination challenges. Organizationally, decentralization of decision-making led to multiple parallel headquarters as different military branches and government agencies established separate command facilities rather than combining into unified structures. The geographic spread reflected both strategy and personal preference, with some locations chosen more for ideology than military logic. The German military was divided into separate service branches with independent command structures. The Army, Navy, and Air Force each maintained separate headquarters, answering to different commanders. In theory, strategic coordination theoretically occurred through combined staff meetings, but in practice, each branch often pursued independent priorities reflecting institutional interests. This division created redundancy, requiring multiple protected command facilities for different services rather than single unified headquarters serving all branches. SS forces operated parallel to regular military structures with their own command hierarchy. SS divisions fought at the front under military operational control, but administrative authority remained with SS leadership rather than Army commanders. Because of this parallel structure required separate SS command facilities and communication networks. The division between military and SS forces complicated operational coordination while multiplying the number of protected facilities leadership deemed necessary for effective command across both structures simultaneously. Civil government administration continued alongside military command structures, requiring additional protected facilities for non-military governance. Occupied territories needed administration beyond military control. Economic planning required coordination separate from tactical military operations. Security services operated throughout German-controlled areas, conducting surveillance and suppression activities distinct from combat operations. Each of these parallel structures demanded protected command spaces and communication facilities, multiplying the total number of installations across the network beyond what unified command would have required. Leadership behaviors reinforced decentralization as senior figures established personal headquarters, reflecting their individual power and independence. Building private command facilities demonstrated status while providing operational independence from rivals. Furthermore, control over protected spaces translated into control over information flows and decision-making processes occurring within those spaces. The proliferation of parallel headquarters therefore reflected both practical coordination challenges and power dynamics among leadership competing for authority and resources within the regime's fractured command structure. Wartime escalation drove defensive architecture requirements to increase sharply after catastrophic damage in major industrial centers showed vulnerability to sustained bombing campaigns. Hamburg's devastation in July 1943 alarmed planners who had underestimated potential destruction from coordinated firebombing. The attack killed tens of thousands, destroyed vast industrial capacity, and demonstrated that even heavily built urban areas could not survive sustained assault from the air. Consequently, this stark lesson prompted immediate reassessment of protection requirements for facilities that absolutely had to continue functioning despite similar attacks. Other cities suffered similar destruction as bombing campaigns intensified through 1943 and 44. Cologne, Essen, Berlin, Munich, and numerous other urban centers faced repeated attacks destroying housing, industries, and infrastructure. Each major raid confirmed that surface structures offered inadequate protection regardless of construction quality. In turn, the cumulative effect of these attacks convinced planners that critical operations needed to move underground where bombing could not reach them. Ultimately, this realization drove the massive Overlagerung program, relocating industrial production beneath mountains and the construction of progressively deeper command bunkers in cities facing sustained aerial campaigns. The escalation affected not just physical structures, but also operational concepts about how warfare would be conducted. Pre-war assumptions about limited bombing gave way to recognition that total aerial warfare targeting entire cities had become reality. As a result, this shift required rethinking protection strategies across the entire system. Simple reinforcement of existing structures proved insufficient. Instead, new facilities required designs assuming direct hits from the most powerful weapons available. Over time, underground spaces became default options for critical facilities rather than exceptional measures for only the most important installations. Resource constraints grew more severe as escalation continued, but simultaneously drove more frantic construction efforts. Germany needed protective facilities precisely when resources to build them became increasingly scarce. Therefore, concrete production competed with other military needs. Steel grew harder to obtain as production declined under bombing. Transportation systems struggled to move construction materials while also supplying military forces and maintaining basic civilian logistics. Yet construction continued and even accelerated because leadership believed protected facilities essential for continuing resistance. This contradiction between growing needs and shrinking resources created impossible pressures that construction organizations could not fully resolve. In fact, prioritization systems attempted to allocate scarce resources to the most critical projects, though political factors often influence priority determinations as much as military necessity. Leadership facilities received highest priority regardless of strategic value. At the same time, symbolic projects important to particular officials sometimes gained resources disproportionate to their actual utility. Meanwhile, border fortifications competed with underground factories for materials and labor. Urban command centers needed resources while military defensive positions went lacking. Throughout this process, committees and bureaucrats made allocation decisions balancing competing demands, but no perfect solution existed when total requirements far exceeded available resources. The prioritization process therefore involved difficult trade-offs, sacrificing some worthy projects to complete others deemed more essential. Working together failures resulted in duplicated efforts where multiple agencies built similar facilities in the same regions without knowing about each other. Consequently, substitution of inferior materials became common practice when preferred supplies were unavailable. Lower quality cement replaced better grades when production couldn't meet demand. Timber formwork reused beyond recommended limits because new lumber was unavailable. In addition, salvaged steel from demolished structures supplemented new production. Alternative aggregates substituted for specified materials when shortages prevented obtaining ideal components. These substitutions degraded construction quality, creating vulnerabilities that might not become apparent until structures faced actual testing under combat conditions. Ultimately, engineering specifications meant to ensure proper protection became suggestions rather than requirements when materials simply could not be obtained. At the same time, black market operations developed around construction materials as scarcity increased their value. Officials with access to supplies sometimes diverted materials for personal profit. Contractors bribed procurement officers for preferential allocation of scarce resources. Workers stole tools and materials for resale. In turn, these corrupt practices siphoned resources from legitimate projects while enriching individuals, exploiting wartime chaos for personal gain. Despite efforts, anti-corruption efforts attempted to control these problems but achieved limited success when systemic scarcity created strong economic incentives for illegal activities and enforcement mechanisms were overwhelmed by the scale of violations. The historical context spanning political rivalries, rearmament strategies, international military developments, operational challenges, leadership behaviors, and bombing escalation created the environment where protected facilities multiplied across German-controlled territory. In the end, these forces combined to produce the specific facilities that became the regime's most important command centers during the war's final years. Early construction reflected confidence about Germany's future, showing power through massive border fortifications and reinforced government buildings. Section 3. Bunkers of isolation. Among these major sites, Wolfschanze occupied a remote area in East Prussian forests as the primary headquarters for Eastern Front operations from 1941 through 1944. The facility was divided into several security zones with controlled movement protocols determining who could access different areas. For instance, Zone 1, the outer perimeter, extended several kilometers into surrounding forest with regular patrols and checkpoint controls on all approach roads. Next, Zone 2, the middle ring, required higher clearance levels and featured more intensive security screening. Finally, Zone 3, the inner zone surrounding leadership quarters and main conference buildings, permitted access only to the most trusted personnel with daily authorization that could be revoked at any time based on security assessments. To its layered security, rail access for rapid deployment of personnel connected Wolfschanze directly to Germany's railway network. A dedicated spur line ran to the facility, allowing trains to deliver visitors, supplies, and equipment without requiring road transport over the final kilometers to the site. This rail connection meant senior commanders from distant fronts could travel directly to headquarters by train, arriving inside the secure perimeter without exposure during transfer from public transportation. The rail link also facilitated evacuation if circumstances required rapid departure, providing alternative transportation if roads became compromised or dangerous. Technical stations for encrypted communication occupied dedicated buildings within the complex. These facilities contained telegraph equipment, radio transmitters, and code machines, processing thousands of messages daily between headquarters and units across the Eastern Front. Operators worked in shifts maintaining continuous communication capabilities regardless of time or operational tempo. In fact, the technical sophistication of these stations rivaled major communication centers and permanent military installations, demonstrating the priority placed on maintaining reliable command contact with forward forces. In fact, private quarters for senior officers stationed on site provided living accommodations, allowing extended residence during critical operational periods without requiring departure from the protected zone. Permanent staff lived on site for months at a time, creating a resident population serving the headquarters on a continuous basis. These officers maintained quarters considerably more comfortable than field conditions, but still austere by peacetime standards. The accommodations reflected military functionality rather than luxury, with emphasis on adequate rest and workspace rather than comfort. Living on site meant officers remained available for urgent consultations or crisis response at any hour, creating an isolated community focused entirely on Eastern Front operations with minimal contact with normal civilian life. Furthermore, medical facilities within Wolfschanze provided basic health care for the resident population and visiting personnel. A small hospital treated routine illnesses and minor injuries that would otherwise require evacuation to civilian hospitals hours away. Medical staff included doctors, nurses, and orderlies maintaining capabilities for emergency surgery if serious injuries occurred. Pharmacy supplies supported ongoing treatments for chronic conditions affecting staff members who could not be evacuated for extended medical care. As a result, the medical facilities ensured that routine health issues did not require personnel to leave the secure complex, maintaining operational security while providing necessary care. Even so, limitations meant serious medical emergencies still required evacuation, but the on-site capabilities handled most situations arising during normal operations. Likewise, Kitchen and mess facilities served hundreds of meals daily for the varying population of permanent staff, visiting commanders, and support personnel. Multiple dining areas separated officers by rank, with senior commanders eating in private spaces while junior officers and enlisted personnel used larger communal facilities. Food quality exceeded standard military rations, particularly for senior ranks, though wartime shortages affected even privileged facilities as the conflict continued. Supplies arrived regularly through the dedicated rail connection, though fresh foods became increasingly scarce during final years as Germany's logistics systems deteriorated under sustained attack. Over time, menus adapted to available supplies while attempting to maintain morale through reasonable food quality. Laundry and maintenance services supported the resident population living in conditions requiring clean uniforms and functioning facilities. Laundry facilities processed clothing for hundreds of personnel with industrial equipment handling the volume. At the same time, maintenance crews kept buildings, utilities, and equipment functioning despite the demanding environment. Heating systems required constant attention during harsh East Prussian winters. Power generation equipment needed regular servicing to ensure reliable electricity. Water treatment maintained sanitary conditions. These support functions employed dozens of workers whose contributions enabled command operations to continue without interruption from basic infrastructure failures. Recreation opportunities remained limited by the isolated location and security requirements restricting movement outside the complex. A small library offered reading materials approved by censors. Occasionally, film screenings provided occasional entertainment when projectors and films were available. In addition, some officers maintained personal hobbies, including photography within permitted areas. Walking paths wound through secure zones, allowing exercise within the perimeter. However, the oppressive atmosphere of isolated military installation combined with knowledge of the war's deteriorating situation created psychological pressures that limited recreation's effectiveness in maintaining morale. Later, many veterans described Wolfschanze as a depressing environment despite relatively comfortable physical conditions compared to combat positions. Middle-period construction showed growing anxiety as the war did not conclude quickly, with facilities expanding despite resource problems. Visiting commanders occupied temporary quarters during their stays for conferences or briefings. These spaces served rotating occupants who arrived for specific purposes, then returned to their field commands. As a result, the rotation of visitors meant Wolfschanze functioned both as permanent headquarters for corps staff and as temporary destination for the broader military leadership community across the Eastern Front. In turn, this dual function required extensive support facilities, including mess halls, meeting spaces, and administrative offices, serving both permanent residents and short-term visitors simultaneously. Rolf Dieter Miller's work describes how this isolated forest complex evolved into a sealed environment where military decisions lost touch with battlefield realities. The very isolation meant to protect leadership instead created a dangerous distance from frontline conditions. The Führer bunker integrated into a larger government complex that housed administrative offices and war planning rooms extending beyond the underground shelter itself. The facility existed as a component within the broader Reich Chancellery compound, spanning multiple buildings and underground connections. Nearby, government ministries maintained offices in adjacent structures, allowing civil administration to continue alongside military command functions. Meanwhile, war planning rooms occupied spaces above the bunker proper, where staff officers prepared situation assessments and drafted operational plans during periods when immediate protection underground was unnecessary. James P. O'Donnell's book, The Bunker, provides the most detailed account, compiled from survivor interviews and physical examination within months of capture. Without this early investigation, critical details about the facility's final days would have been lost forever as survivors scattered and memories faded. Overall, this integration created a vertical government structure where administrative layers occupied different physical levels based on security requirements and protection needs. Routine paperwork occurred in surface offices during quiet periods. During heightened alerts, important meetings convened in reinforced spaces during elevated threats. Then, critical operations retreated to the deepest underground levels during direct attacks. The system allowed government function to continue by shifting between these levels as circumstances demanded, maintaining operational continuity despite bombing that would have paralyzed any system dependent on single-level facilities. In terms of structural protection, reinforced ceilings designed to withstand heavy aerial munitions went beyond standard concrete thickness found in surface structures. Engineers calculated stress loads from the most powerful bombs in Allied inventories, then designed ceilings capable of surviving direct hits from these weapons. Specifically, multiple layers of reinforced concrete alternated with air gaps, creating composite structures that distributed impact forces across larger areas rather than concentrating them at single points. This design absorbed explosive energy that would have penetrated solid concrete of comparable total thickness. The reinforcement extended throughout structural elements, supporting these enhanced ceilings. Walls required strengthening to handle lateral forces from near-miss explosions. Support columns needed extra capacity to handle loads if ceiling sections were partially damaged but not completely destroyed. Similarly, floor structures had to support weight from collapsed materials if upper levels suffered damage. The entire structural system worked together as integrated protection rather than relying solely on individual reinforced elements. Constructed with emergency escape corridors connected to adjacent buildings, provided multiple exit routes if primary entrances became blocked or compromised. These alternate passages ran through the surrounding government complex, creating networks of protected pathways allowing movement between different buildings without exposure to surface conditions. For instance, during bombing raids, personnel could shift between structures using these tunnels, seeking undamaged exits if their current location suffered hits blocking normal access routes. The emergency corridors served additional functions beyond pure escape routes. They allowed secure movement between different government offices without exposure to observation or weather. They created protected communication routes where couriers could move between departments carrying classified materials without surface transport. They provided alternative access for essential supplies if normal delivery routes were interrupted. The corridors therefore functioned as both emergency systems and everyday logistics networks integrated throughout the larger government complex. In fact, it contained storage areas for documents and command materials accumulated throughout military operations across multiple fronts. Maps required secure storage when not actively in use during planning sessions. Intelligence reports needed organized filing, allowing rapid retrieval when information became relevant to developing situations. Orders issued to field units required copies for reference if questions arose about specific directives. Personnel files on officers required protection and accessibility for assignment decisions. Equipment inventories, supply reports, casualty records, and countless other documents supporting military operations demanded protected storage accessible to staff officers requiring information for daily work. Over time, document security became increasingly important as the war continued and the volume of classified materials grew rapidly. Final phase construction from 1943 to 45 showed pure desperation as Germany's position collapsed beyond any hope of recovery. Paper accumulated faster than storage capacity could expand, creating organizational challenges managing the sheer quantity of documents generated by total war. Filing systems required constant updating and reorganization as operational priorities shifted. As a result, staff dedicated to document management worked continuously maintaining order in the growing archives. The storage areas within the bunker and connected facilities therefore, represented not just physical space, but also complex information management systems essential for effective command of forces spread across vast territories. To maintain internal control, security protocols for document handling specified who could access different classification levels, how material should be stored when not in use, and procedures for destroying sensitive papers if capture became imminent. Guards monitored document storage areas, verifying that only authorized personnel entered. Sign-out systems tracked which officers had specific documents at any time. Secure destruction procedures used incinerators or shredders, though the volume of paper sometimes overwhelmed destruction capabilities when urgent evacuation became necessary. In the end, the documentary security system attempted to prevent intelligence from falling into enemy hands while maintaining accessibility for legitimate operational needs, a balance that became increasingly difficult as circumstances deteriorated. At the same time, communication with the outside world depended entirely on technical systems connecting the isolated underground facility to broader network. Telephone lines ran through protected conduits connecting to exchanges throughout Berlin and beyond. Similarly, radio transmitters broadcast orders to military units when telephone connections failed or were too risky for sensitive communications. Telegraph systems provided written message capabilities with encoding protecting classified contents. Courier services supplemented electronic communications, with messengers carrying documents between the bunker and other government offices throughout the city. Together, this multi-layered communication network created redundancy, ensuring contact could continue even when individual systems failed, though the general deterioration of Berlin's infrastructure progressively degraded overall communication capabilities during the final months. Personnel assignments rotated between the bunker and other duties as circumstances required different specialists at various times. Military officers came and went, depending on operational requirements and whether their expertise was needed at headquarters or in field positions. During bombing raids, civil administrators maintained offices in the bunker complex when bombing made surface work impossible. Meanwhile, guards rotated through shifts maintaining continuous security. Support staff, including clerks, telephone operators, and maintenance workers, provided services enabling command operations to continue. Eventually, the rotating personnel created a fluid population where some individuals remained for extended periods, while others stayed only days or weeks before moving to different assignments. The Eagle's Nest was positioned to function as a high-altitude meeting point for diplomatic meetings involving foreign officials visiting Germany. The dramatic mountain setting impressed visitors, while the remote location provided privacy for sensitive discussions away from diplomatic community observation in Berlin. The facility allowed informal conversations outside normal government protocols, while simultaneously showcasing German engineering capabilities through the elaborate construction itself. Foreign dignitaries who made the journey to this remote alpine location experienced both hospitality and subtle intimidation from the significant effort required merely to access the facility. In fact, weather station equipment monitored mountain conditions, providing data used for aviation safety, military planning, and general meteorological research. The high-altitude location offered valuable observation points for atmospheric conditions at elevations where most German territory lacked permanent installations. Meteorologists staffed the weather station recording temperature, barometric pressure, wind speed, precipitation, and visibility data. In turn, this information supported flight operations in the region, provided forecasting data for military purposes, and contributed to broader understanding of alpine weather patterns. Therefore, the weather station served practical purposes beyond the facility's primary diplomatic and symbolic functions. Scientific research conducted at the facility included high-altitude physiology studies examining how humans adapted to reduced oxygen levels. Medical researchers used the location to study altitude effects on physical and cognitive performance, gathering data relevant to aviation medicine and military operations in mountainous terrain. Test subjects underwent controlled exercises at various elevation levels, while researchers measured physiological responses. The research contributed to understanding about altitude acclimatization, oxygen requirements, and performance limitations affecting military operations conducted at high elevations throughout occupied territories in mountainous regions. Communication systems at the Eagle's Nest required special engineering addressing challenges of maintaining reliable contact from an isolated mountaintop location, subject to severe weather interfering with radio transmission. Telephone lines ran through the access tunnel and down the mountain road to connect with regional networks. At the same time, radio systems provided backup communications when telephone lines failed during storms. Emergency signaling equipment allowed contact during catastrophic system failures. The redundant communication systems ensured the facility could maintain contact with lower elevation government offices and military commands, regardless of weather conditions disrupting individual communication methods. Material needs strained Germany's economy as construction accelerated, consuming thousands of tons of concrete and steel desperately needed elsewhere. Meeting spaces emphasized views and natural beauty rather than the cramped functionality characteristic of most military installations. Large windows showcased mountain panoramas extending hundreds of kilometers across the Alps. Simultaneously, the interior decoration featured quality materials and artwork, creating an atmosphere more suited to diplomatic reception than military conference. This emphasis on aesthetics served propaganda purposes, presenting an image of power and culture designed to influence foreign observers' perceptions of the regime's strength and sophistication. Designed with anti-observation methods to reduce aerial visibility from Allied surveillance aircraft, incorporated camouflage, considering the unique challenges of concealing structures at extreme altitude. The stone construction blended with natural rock faces visible from aerial perspectives. The compact building footprint minimized silhouette visible from overhead surveillance. Color choices matched surrounding rock and vegetation from aerial viewing angles. While not perfect, these measures reduced how obviously it stood out during photographic surveillance missions, scanning for significant installations throughout German-controlled territory. Beyond camouflage, the mountain setting itself provided significant protection because attacking such a remote, high-altitude target required diverting aircraft from more militarily significant objectives closer to combat zones. Allied planners recognized the propaganda value of the facility, but assessed its destruction as poor use of limited bomber resources, given the minimal military importance and extreme difficulty of accurate bombing against a small target in mountainous terrain with unpredictable weather and dangerous flying conditions. It contained specialized ventilation for high-elevation air conditions that addressed the technical challenges of maintaining breathable atmosphere at altitudes where reduced oxygen affects both humans and mechanical systems. The ventilation system needed to compensate for thinner air while maintaining comfortable temperature despite extreme cold at mountain peak elevations. Heating sufficient for winter conditions required substantial energy expenditure. The system balanced these competing demands while maintaining reliable operation despite the harsh environmental conditions characterizing high alpine settings. Health considerations influenced ventilation design because people unaccustomed to altitude experienced headaches, shortness of breath, and fatigue affecting their ability to conduct productive meetings or work effectively. The system attempted to optimize conditions for visitors arriving from lower elevations who needed to function effectively during diplomatic gatherings or government meetings. This meant maintaining higher oxygen concentrations than natural at that altitude, while avoiding excessive pressurization that might create its own physiological problems. used materials resistant to harsh mountain climate variations, withstanding extreme temperature swings between winter cold and summer heat, intense solar radiation at high altitude, heavy snow loads during winter months, and moisture infiltration from precipitation and condensation. Building materials needed to maintain structural integrity through repeated freeze-thaw cycles that could crack inadequate materials. Stone construction provided durability against these challenges, while also offering aesthetic qualities desired for the facility's diplomatic purposes. In fact, maintenance requirements reflected the demanding conditions characterizing high mountain environments. Regular inspections checked for weathering damage requiring repair before minor problems escalated. Heating systems needed continuous attention, ensuring reliable operation during cold months when failure could quickly create dangerous conditions. Similarly, the access road and tunnel required clearing after snowstorms and maintenance addressing weather damage. Meanwhile, the elevator system demanded careful servicing to ensure mechanical reliability despite operating in challenging environmental conditions. In the end, these ongoing maintenance demands meant the facility required continuous support even during periods when actual occupancy remained minimal. Diplomatic functions at the facility combined practical meetings with propaganda purposes showcasing German capabilities. Foreign dignitaries invited to the Eagle's Nest experienced an elaborate display of engineering achievement and organizational capacity. The difficult journey to the remote mountaintop location became part of the experience, demonstrating German willingness to expend enormous resources on ambitious projects. During visits, conversations in this dramatic setting aimed to impress visitors with German power and determination. Afterward, photographs of meetings at the Eagle's Nest appeared in international media, serving propaganda objectives by associating leadership with dramatic alpine imagery, suggesting strength and permanence. Staff supporting diplomatic functions included interpreters, protocol officers, and hospitality personnel, ensuring smooth operations during official visits. Interpreters handled communications when foreign guests spoke different languages. Protocol officers managed ceremonial aspects of visits, ensuring proper treatment of dignitaries according to their rank and national customs. Kitchen staff prepared meals suitable for formal diplomatic entertaining. Housekeeping maintained the facility in presentable condition for important visitors. The support staff made diplomatic use of the facility possible, though their efforts often went unrecognized in historical accounts focusing on more prominent figures and major events. Workforce makeup reflected regime priorities, with concentration camp prisoners deliberately worked to death under conditions designed to extract maximum effort. Security for diplomatic visits required coordination between multiple agencies protecting both German leadership and foreign dignitaries. Background investigations vetted all foreign visitors before visits were approved. Next, travel routes from lower elevations to the mountaintop facility received security screening. Throughout visits, guards maintained control over access throughout visits. Communication security prevented unauthorized monitoring of diplomatic conversations. These security measures operated discreetly, maintaining the appearance of relaxed hospitality while actually providing comprehensive protection against potential threats. In the end, the balance between security and diplomatic atmosphere required careful management, ensuring safety without creating an obvious military atmosphere that might offend guests or undermine the intended impression of confident strength. Limited actual use of the facility for its intended diplomatic purposes raised questions about whether the enormous investment was justified by results achieved. The infrequent visits meant the facility sat unused most of the time despite continuous maintenance requirements. Hans-Günter Klein's research on Obersalzberg confirms this pattern of wasted resources. The Führer visited fewer than 15 times total, yet the expensive facility appeared constantly in propaganda photos, projecting strength to the German public. This massive investment served image rather than military value, showing how ideological priorities trumped practical needs throughout the construction program. Alternative locations could have served diplomatic purposes at far lower costs. However, propaganda value and personal prestige associated with the facility justified the expenditure in leadership calculations, even when objective analysis would suggest the resources were wasted. Ultimately, this pattern of valuing symbolic impact over practical utility characterized numerous regime projects where ideological or personal factors outweighed rational cost-benefit assessments. These three major command sites represented the regime's most significant protected headquarters facilities during the war years. However, they formed only part of a much larger network, including underground production sites, symbolic installations, and urban facilities serving different purposes within the overall strategic system. Inspection methods varied wildly between facilities, with some receiving detailed oversight while others operated with minimal supervision where quality suffered badly. Section 4. Factories beneath mountains. Within this system, the Überlagerung program's underground factories contained rail spurs inside tunnels for material transport, allowing trains to deliver raw materials directly to production chambers without requiring extensive surface handling. These internal rail lines reduced exposure to aerial observation while providing efficient logistics for moving heavy materials and completed weapons. The rail systems extended into mountain tunnels, with tracks laid on level gallery floors allowing standard rolling stock to access underground assembly areas. In addition, sidings permitted multiple trains to operate simultaneously, with some delivering incoming materials while others loaded completed products for shipment to military units. As a result, integration of rail transport directly into production spaces eliminated bottlenecks that would have occurred if materials required transfer from surface rail terminals into underground facilities through other means. Direct rail access meant efficiency approaching surface factories despite the unusual location. Ultimately, heavy machinery, large weapons components, and bulk materials could move by train to positions immediately adjacent to where they would be used in production. This integration represented complex logistics planning, adapting normal industrial operations to unconventional underground settings. At the technical level, specialized lighting systems designed for low-oxygen tunnel environments addressed the challenge that standard combustion-based lighting could not operate effectively in sealed spaces with limited oxygen. Early tunnel systems attempted using oil lamps or gas lighting, but discovered these created dangerous carbon dioxide buildup while consuming oxygen needed by workers. Electric lighting solved this problem, while also providing better illumination quality for precision manufacturing tasks. However, the electrical systems required substantial power generation capacity to illuminate extensive tunnel networks where no natural light penetrated. Lighting placement reflected specific production requirements at different work areas. Assembly lines needed bright, even illumination, minimizing shadows that could hide defects or make precision work difficult. Inspection stations required especially intense lighting, allowing quality control personnel to identify problems with manufactured components. By contrast, storage areas received less intensive illumination sufficient for material handling without wasting power on continuously lit spaces that workers only entered occasionally. The lighting design balanced these varying requirements while managing overall power consumption in systems, depending entirely on diesel generators isolated from external electrical grids. Included underground administrative offices to manage production cycles, housing supervisors, engineers, and production coordinators directing the daily operations of underground manufacturing facilities. These offices occupied chambers adjacent to production areas, allowing administrators to oversee operations while remaining protected within the underground complex. Production managers tracked output against quotas, investigating reasons for shortfalls and addressing bottlenecks slowing manufacturing. At the same time, engineers solved technical problems affecting equipment or production processes, modifying systems as needed to improve efficiency or reliability. Meanwhile, quality control supervisors reviewed inspection reports and made decisions about accepting or rejecting completed units. Therefore, the administrative functions continued within protected spaces, just as production itself occurred underground. Record-keeping presented special challenges in humid underground environments where paper documents deteriorated rapidly without special storage. Administrative offices needed climate control, protecting files from moisture damage while maintaining comfortable working conditions for clerical staff handling paperwork. Typewriters, filing cabinets, calculating machines, and other office equipment required adaptation to underground conditions. The offices represented attempts to replicate normal factory administration in decidedly abnormal physical environments deep beneath the surface. To logistics and lighting, it featured controlled temperature and humidity zones for certain armaments, requiring specific environmental conditions for proper assembly and storage. Some explosives and propellants are sensitive to temperature variations that could affect their stability or performance. Similarly, precision mechanisms demanded low humidity, preventing rust of metal components or moisture absorption by certain materials. Meanwhile, electronics required dry conditions, protecting circuits from moisture that could cause shorts or gradual degradation. As a result, creating these controlled zones within mountain tunnels required complex environmental systems, isolating specific areas from the generally damp, cold conditions characterizing most underground spaces. Moreover, the technical systems maintaining controlled environments consumed significant energy while requiring continuous monitoring, ensuring proper operation. Heating systems, dehumidifiers, air circulation equipment, and temperature monitoring instruments all needed regular maintenance. Because of this, redundant systems provided backup because environmental system failures could damage valuable weapons or materials. The investment in controlled environments added substantial costs beyond basic tunnel excavation and production equipment installation. But military requirements for certain weapons demanded these specialized conditions regardless of difficulty creating them underground. Living conditions varied dramatically between skilled German employees and forced laborers, revealing complete disregard for human life when it conflicted with schedules. In fact, production scheduling in underground factories faced unique constraints compared to surface facilities. Limited entrance points created bottlenecks for material delivery and finished product removal. Underground transportation used small rail cars or trucks moving through restricted tunnel widths. At the same time, assembly line configurations adapted to tunnel shapes rather than optimal production flow patterns. Worker shifts coordinated around ventilation system capabilities that might become overwhelmed if too many people worked simultaneously in confined spaces. As a result, these constraints meant production rates often fell below what equivalent surface facilities would achieve, though protection from bombing provided compensating advantages once surface alternatives were destroyed. Quality assurance programs attempted to maintain production standards despite challenging working conditions. Inspectors checked components at multiple production stages, rejecting defective items before they advanced to final assembly. Next, testing procedures verified that completed weapons functioned according to specifications. Statistical sampling monitored overall quality trends, identifying problems requiring systematic corrections. However, the pressure to meet production quotas sometimes led to accepting marginal quality items that properly should have been rejected. Ultimately, this tension between quantity and quality affected military effectiveness when weapons failed during operations due to manufacturing defects traceable to inadequate underground production conditions or insufficient quality control. André Sellier documented Mittelwerk's operations through painstaking research combining survivor testimony with physical evidence and captured German records. His work revealed a horrifying truth that disturbed even Allied investigators who had witnessed concentration camps. More workers died building V-2 rockets at Mittelwerk than those weapons would ever kill in combat. This brutal calculation exposes the moral bankruptcy at the heart of underground production, where human life counted for nothing against production quotas. Worker health deteriorated rapidly in underground environments lacking adequate nutrition, medical care, or humane working conditions. Respiratory diseases spread through crowded tunnels with poor air quality. Injuries from industrial accidents received minimal treatment. Malnutrition weakened immune systems, making workers susceptible to infections that healthy populations would resist. The regime's complete disregard for worker welfare meant that addressing health issues through better conditions never received serious consideration. As a result, workers died from preventable causes, while production continued using replacement prisoners delivered from concentration camp networks, specifically to maintain workforce numbers as deaths mounted. Michael Neufeld's research on underground rocket production exposes this terrible math. Germany poured resources into technically advanced weapons that delivered minimal strategic value. More workers died building V-2 rockets than those weapons would ever kill in combat. The underground factories became monuments to misplaced priorities, where engineering achievement cost thousands of lives for weapons that never changed the war's outcome. Even so, the Alpine Redoubt myth spread through channels despite lack of unified construction, reflecting intelligence confusion, propaganda exaggeration, and genuine defensive preparations that were misinterpreted or exaggerated beyond their actual scale. Defense plans circulated through multiple military channels as staff officers considered various scenarios for continuing resistance if Germany lost control of northern territory. These plans existed mostly as theoretical exercises, exploring options, rather than as active construction programs, receiving major resource commitments. In intelligence assessments, maps referencing the region appeared in classified intelligence reports when Allied intelligence services attempted to assess German defensive intentions as military forces contracted toward southern territory. Captured documents mentioning Alpine defensive positions were analyzed for indications of broader defense strategies. Surveillance photographs showed some fortification work in mountain regions, though significantly less than the elaborate fortress network intelligence estimates sometimes suggested. Prisoner interrogations produced conflicting information, as some German soldiers genuinely believed in substantial Alpine defenses based on rumors, while others could provide no specific details because the defenses largely did not exist as described. Intelligence analysts faced difficult interpretative challenges, distinguishing between actual construction programs and strategic deception or wishful thinking by German planners. The possibility of last-ditch resistance from mountain redoubts seemed plausible given German leadership's ideological commitment to fighting to the end. This plausibility made intelligence services take reports seriously, even when hard evidence remained limited. The resulting estimates sometimes overstated actual defensive preparations, influencing Allied strategic planning in ways that benefited Germany by causing caution about southern advance routes. Mountain passes were surveyed for potential withdrawal corridors, allowing German forces to retreat into defensible Alpine terrain if northern positions collapsed. These surveys identified routes suitable for military traffic, locations appropriate for blocking positions, and areas where defenders could establish strong points controlling access. The surveys represented contingency planning rather than committed construction programs, but their existence lent credibility to claims about Alpine fortress preparations. In fact, military maps showing surveyed routes appeared in captured documents, reinforcing intelligence assessments about German defensive intentions. The surveying also identified challenges making sustained Alpine defense impractical. Mountain terrain offered defensive advantages, but severely limited logistics. For example, supplying large military forces in isolated Alpine valleys through mountain passes would strain supply systems even without enemy interdiction. Winter conditions would make operations difficult or impossible for months each year. The surveys therefore revealed both potential advantages and severe limitations of Alpine defensive positions, though intelligence analysis sometimes emphasized advantages while underestimating logistical constraints. Concealed urban sites formed a category so effective that many operated undetected throughout the entire war despite functioning in plain sight. However, supply depots in isolated valleys contributed to the myth's persistence by providing tangible evidence that Germans prepared for sustained operations in mountain regions. These depots stored ammunition, food, fuel, and medical supplies sufficient for weeks or months of continued operations. Their existence confirmed that some defensive preparation occurred, lending credibility to more elaborate estimates about full-scale fortress construction. In reality, the actual quantities stored fell far short of what truly sustained defense would require, and many depots supported occupation forces in mountain regions rather than representing specific preparation for last-ditch resistance. Inventory records captured after the war revealed the actual supply quantities, showing they could not support extended resistance by the forces intelligence had estimated might retreat into Alpine positions. However, during the war's final months when these estimates mattered most for operational planning, Allied commanders lacked detailed knowledge about actual supply levels. As a result, the visible existence of supply facilities therefore reinforced beliefs about German defensive preparations, regardless of whether those preparations could realistically sustain major operations. Strategic impact of the redoubt myth extended beyond simple intelligence confusion to influence Allied operational decisions during the war's final months. Some military planners advocated rapid advance into northern Germany, even if this meant temporarily bypassing southern regions where the supposed Alpine fortress existed. By contrast, others argued for methodical clearing of all territories, including careful approach to Alpine regions that might harbor large German forces. These debates consumed leadership attention and planning resources during critical periods when decisions about force deployments affected how quickly the war would conclude. The myth therefore achieved strategic effects despite minimal reality behind the reports. Earl F. Ziemke's mapping work for the U.S. Army Historical Division later proved the supposed Alpine fortress was largely imaginary. His documentation of actual defensive installations showed they bore no resemblance to the elaborate mountain strongholds in wartime intelligence reports. The reputation of these supposed facilities influenced Allied strategy more powerfully than any real fortifications ever could have. German exploitation of the redoubt myth remains disputed among historians, examining whether leadership deliberately encouraged Allied misperceptions or whether the myth developed independently through intelligence confusion. Some evidence suggests German officials made statements intended to create an impression of Alpine defensive preparations. In contrast, other evidence indicates that various defensive planning discussions occurred without coordinated deception programs. The truth likely combined elements of both explanations, with some officials seeing value in encouraging Allied caution about Alpine approaches, while actual defensive preparations remained far more limited than intelligence estimates suggested. Propaganda elements emphasized mountain stronghold concepts and materials aimed at both domestic and international audiences. German media suggested that resistance would continue from mountain redoubts, even if northern territories fell. Speeches referenced Alpine fortress ideas without providing specific details. These propaganda efforts aimed partly to maintain German morale by suggesting that final defeat could be avoided through retreat to prepared mountain positions. International audiences were meant to see Germany as possessing continued resistance capabilities even after losing most territory. Therefore, the propaganda served multiple purposes while contributing to the broader myth about Alpine defenses that influenced Allied intelligence assessments. Wewelsburg Castle contained research rooms for SS historical studies, pursuing Heinrich Himmler's ideological obsessions with racial history, Germanic mythology, and pseudo-scientific theories about Aryan origins. These research spaces housed scholars conducting studies intended to provide historical justification for regime racial ideology. Researchers examined archaeological evidence with predetermined conclusions, interpreting findings to support regime beliefs about Germanic superiority. Medieval texts received analysis emphasizing supposed Germanic traditions. Genealogical research attempted to trace pure bloodlines through historical records. In the end, the scholarly work served propaganda rather than genuine academic inquiry, producing materials supporting ideological indoctrination rather than advancing historical understanding. In fact, libraries within research facilities collected books, manuscripts, and documents related to Germanic history and culture. Acquisitions prioritized materials supporting ideological interpretations while ignoring or suppressing works challenging regime beliefs. Often, rare books and manuscripts were sometimes seized from conquered territories, with valuable items redirected to Wewelsburg collections. The library therefore combined legitimate historical materials with ideologically filtered collections serving propaganda purposes. In parallel with these research activities, storage developed for cultural artifacts collected by the regime through seizure from occupied territories and targeted acquisition of items considered significant to Germanic heritage. Storage facilities protected artifacts from bombing while making them available for study or ceremonial display. Some collections included significant archaeological finds with genuine historical value, despite the ideological framework distorting their interpretation. By contrast, other materials lacked scholarly merit but served symbolic purposes within SS ideology. Ultimately, the artifact collections represented theft on a massive scale, with occupied territories stripped of cultural treasures redirected to SS facilities. To preserve these materials, climate-controlled storage protected valuable artifacts from deterioration, requiring environmental systems maintaining stable temperature and humidity. Security measures prevented unauthorized access to collections containing irreplaceable items. Catalog systems tracked individual pieces, allowing researchers to locate specific artifacts for study. The storage facilities therefore combined museum functions with security installations, protecting collections that leadership valued for ideological reasons beyond any objective historical or artistic merit. Converting existing structures presented different challenges. Forcing engineers to work around limitations of buildings never meant for military purposes. The facility served as a training site for organizational indoctrination programs, developing SS leadership and teaching members in regime ideology through structured programs. In fact, training programs at Wewelsburg educated SS officers in supposed Germanic traditions, racial theories, and leadership principles defined by SS ideology. Courses combined ideological indoctrination with practical military and administrative training. During these sessions, participants lived on site during training periods, experiencing communal routines intended to reinforce SS identity and values. The training programs produced cadres who then implemented policies throughout occupied territories, spreading SS ideology through administrative structures controlling millions of people. Ceremonial spaces hosted rituals intended to replace traditional religious practices with SS-specific alternatives emphasizing loyalty to organization and leadership above other values. These ceremonies used Germanic symbolism and references to medieval traditions, creating pseudo-religious experiences reinforcing SS identity. In the end, the ceremonial functions served psychological purposes, binding members to the organization through shared rituals and symbols distinct from broader society. Structural modifications were designed to reshape the building's internal symbolism toward Heinrich Himmler's vision of the castle as an SS spiritual center. Construction modified the North Tower specifically for ceremonial purposes, with a circular room on the ground floor and crypt-like space below serving ritual functions. The modifications created spaces without practical administrative purposes, existing purely for symbolic and ceremonial reasons. The construction consumed resources throughout the war despite contributing nothing to military effectiveness, demonstrating how ideology sometimes overrode practical considerations in facility construction. The modifications required extensive masonry work, specialized stone cutting, and artistic detailing, creating symbolically significant spaces. Craftsmen worked on decorative elements with no military value while soldiers fought with inadequate equipment and supplies. Ultimately, the contrast between resource investment in symbolic construction versus military necessities revealed leadership priorities placing ideological satisfaction above effective prosecution of the war effort. Urban facilities operated with concealed message drop points, used by intelligence units coordinating surveillance and counterintelligence operations. These drops allowed agents to pass information without direct contact that might expose their connections to security services. Dead drops used locations like hollows in walls, spaces behind loose stones, or containers hidden in public areas where one agent could deposit materials for retrieval by another without requiring simultaneous presence. The system allowed intelligence networks to function despite Allied counterintelligence efforts attempting to identify and neutralize German intelligence operations in occupied territories. Accordingly, drop points were selected for accessibility without arousing suspicion, locations where people naturally congregated or passed regularly without unusual activity being noticeable. Train stations, public parks, markets, and similar areas provided cover for agents making drops or retrievals as part of seemingly normal civilian activities. Finally, the urban environment's natural anonymity protected intelligence operations that would have been impossible in smaller communities where unusual behavior attracted immediate attention. To drop sites, some locations connected to covert courier routes moving sensitive materials between facilities without using normal postal or telegraph systems that might be monitored or intercepted. Couriers traveled established routes, making regular deliveries that appeared routine but actually moved classified documents, intelligence reports, or orders between command nodes. As a result, the courier networks created parallel communication systems independent of conventional channels, providing redundancy and security for the most sensitive materials, requiring absolute protection from enemy intelligence. Route planning balanced security against efficiency, seeking paths that avoided observation while still allowing reasonable travel times. Couriers used transportation that would not attract attention, sometimes posing as business travelers or making deliveries for legitimate companies that unknowingly provided cover. To maintain security, the routes changed periodically, preventing patterns from developing that might be detected through surveillance. Backup routes existed if primary paths became compromised or dangerous due to military operations or security concerns. Digging through solid rock needed specialized drilling equipment and careful explosive placement that made progress slow and dangerous for workers. Certain buildings operated dual-function spaces disguising restricted access behind facades of legitimate business or government activities. A room might appear to serve normal commercial purposes, with authentic operations conducted there regularly, while also containing hidden spaces or equipment serving intelligence functions. Thus, the dual purpose created effective cover because observers saw genuine activity consistent with the building's stated purpose, not recognizing that additional restricted activities occurred in concealed spaces or during specific hours when legitimate business was closed. Many sites had reinforced partitions hidden behind standard interior walls, creating protected spaces within otherwise ordinary buildings. So these hidden reinforcements meant that external observers, and even building occupants in unrestricted areas, could not determine that protective structures existed within the building. The reinforced partitions provided protection comparable to purpose-built bunkers while maintaining external appearances of normal civilian construction. In practice, creating these hidden reinforcements required careful construction where modifications occurred inside existing buildings without visible external changes that might attract attention or reveal the building's dual purpose. In addition, acoustic insulation accompanied physical reinforcement, ensuring that activities in restricted spaces could not be overheard by people in adjacent, unrestricted areas. Soundproofing prevented conversations or mechanical noises from protected spaces, betraying their existence to building occupants or passers-by. In the end, the acoustic measures complemented physical concealment, creating multi-layered security where the existence of restricted spaces remained secret, even from people working in the same buildings who lacked authorization to know about hidden facilities. This meant ventilation presented technical challenges because protected spaces needed independent air supplies preventing smoke or chemical agents from entering through normal building ventilation. However, these independent systems had to operate without creating noticeable noise or external venting that might reveal hidden spaces. To address this, engineers designed quiet ventilation systems with concealed external vents, appearing identical to normal building features. The technical sophistication required for truly hidden protected spaces within urban buildings exceeded that of isolated rural bunkers where concealment relied primarily on location rather than architectural deception. Because of this, personnel access control in urban facilities required different approaches than isolated installations with obvious perimeter security. Building entrances appeared normal, with guards disguised as doormen or building staff. Once inside, identity verification occurred in reception areas resembling ordinary business lobbies. Elevator access required special keys or operator assistants directing cars to restricted floors. Stairwell doors to secure areas used locks indistinguishable from normal fire doors. Eventually, this layered security maintained operational security while allowing facilities to function in dense urban environments where obvious military security would attract immediate attention from residents and intelligence services. Also, cover stories for urban facilities required careful maintenance because neighbors and local authorities needed plausible explanations for building uses that might otherwise arouse suspicion. Front businesses maintained minimal legitimate operations providing cover for actual intelligence activities. At the same time, residential buildings included a few genuine residents whose presence gave the appearance of normal occupancy. Meanwhile, office buildings conducted some actual administrative work alongside covert operations. Ultimately, these cover operations consumed resources but provided essential security through deception, allowing facilities to operate undetected while intelligence gathering or communications continued in hidden spaces. To facilitate this, equipment concealment within urban buildings required creative solutions, hiding specialized devices behind false walls or beneath floor spaces. Radio transmitters occupied concealed rooms with antennas disguised as normal building features. Telephone switchboards handling classified communications sat behind false bookcases or filing cabinets. Meanwhile, encoding machines used for message encryption were stored in locked safes appearing to contain ordinary business records. Weapons caches for facility defense hid in walls or ceiling spaces. In the end, the concealment allowed facilities to appear completely normal during inspections while maintaining operational capabilities for their actual covert purposes. Emergency evacuation plans for urban facilities considered scenarios where normal exits might be compromised by bombing, fire, or enemy action. Foundation engineering became progressively more complex as facilities grew larger and protection needs exceeded original design parameters. This examination of underground factories, symbolic installations, and urban facilities reveals the network's diversity beyond obvious command centers. The system combined military, industrial, ideological, and intelligence functions into an interconnected structure serving multiple regime purposes simultaneously. Therefore, understanding how these different elements fit together requires examining the network's overall functioning and ultimate failure during the war's final phase. Concrete formwork presented logistical challenges because pouring massive walls needed temporary structures consuming scarce lumber and skilled carpenters. Section 5. When protection became prison. These dispersed sites formed a multi-layered system combining protection, deception, and operational continuity. Underground factories maintained weapons production despite surface infrastructure destruction. Urban facilities preserved intelligence and administrative capabilities in cities facing sustained bombing. Symbolic installations reinforced ideological control over SS and party structures. Ultimately, the system functioned because different facility types complemented each other, creating redundancy where loss of individual sites did not catastrophically compromise overall capabilities. In simple terms, protection worked through physical barriers, concealment, and distributed operations. Thick concrete walls absorbed explosive impacts that would have destroyed surface buildings. Underground placement removed facilities from aerial attack entirely. In addition, camouflage reduced detection probabilities. Geographic dispersal meant no single bombing raid could eliminate critical capabilities concentrated at one location. Furthermore, multiple parallel command centers allowed operations to continue if primary facilities were attacked or captured. In the end, the multi-layered protection reflected recognition that no single defensive approach could ensure survival against sustained Allied efforts to destroy German command and control systems. At the same time, deception served both operational and strategic purposes throughout the network's existence. Camouflaged facilities avoided detection by surveillance aircraft. Urban facilities operated while appearing to be normal civilian buildings. Also, dummy installations drew attacks away from actual critical sites. The Alpine redoubt myth influenced Allied planning despite minimal reality behind the reports. These deception efforts complicated Allied intelligence assessments, forcing them to investigate numerous suspected facilities while actual critical installations sometimes escaped detection through more effective concealment than suspected sites where deception deliberately drew attention. In fact, operational continuity depended on communication systems, supply stockpiles, and personnel redundancy, allowing command functions to survive despite attacks on specific facilities. Each major command center maintained independent communication systems capable of reaching forces even if other facilities were destroyed. Additionally, supply depots distributed throughout the network meant that losing individual storage locations did not immediately compromise operations. Key personnel could shift between facilities if their primary location became untenable. Eventually, these continuity measures bought time, allowing operations to continue longer than would have been possible without protected facilities, though ultimately they merely delayed rather than prevented the regime's final collapse. Surviving records include architectural plans, intercepted communications, and post-war analysis by Allied investigators examining the network's extent after Germany's surrender. Architectural plans captured from government offices and construction companies revealed facility designs, locations, and capabilities. These documents showed what engineers built, where they built it, and how they designed protection systems. The plans answered technical questions about structural strength, ventilation capacity, communication systems, and other specific features. However, plans sometimes showed proposed facilities never actually constructed, requiring investigators to distinguish between approved projects and completed installations through verification against other evidence. Intercepted communications provided operational intelligence about how facilities functioned during the war years. Signals intelligence revealed message traffic between headquarters and field units, indicating which facilities served as active command centers and when. In addition, communication analysis showed network patterns connecting different installations, revealing organizational relationships between facilities. Meanwhile, intercepted orders indicated leadership locations at specific times, helping reconstruct movement patterns and facility usage. In the end, this intelligence created operational understanding complementing the physical details from architectural records. Post-war analysis by Allied investigators examining the network's extent after Germany's surrender combined these sources with physical inspection of actual facilities. Investigation teams visited sites, photographed structures, interviewed captured personnel, and compiled comprehensive reports. These teams discovered previously unknown installations, confirmed intelligence estimates, and disproved some reports about facilities that never actually existed. The systematic investigation revealed the network's true extent, separating reality from wartime intelligence estimates that sometimes overstated or misunderstood actual German capabilities. Investigative reports documented evidence of forced labor use throughout construction projects. Mass graves near underground factories provided physical proof of deaths among forced workers. Survivor testimony described brutal conditions and systematic mistreatment. Construction records sometimes listed worker casualties with callous notation, treating human deaths as administrative details. The documentation supported later war crimes prosecutions while creating a historical record of atrocities committed during facility construction. Concrete mixing demanded careful quality control because incorrect mixes weakened structures, potentially compromising protective ability when it mattered most. Prosecution of war crimes related to facility construction faced challenges gathering sufficient evidence and identifying responsible individuals years after events occurred. Many key figures died during the war or avoided capture afterward. Witnesses were sometimes deceased or could not be located. Documentary evidence was incomplete because records were destroyed during evacuations or lost in post-war chaos. Some prosecutions succeeded in holding individuals accountable for specific crimes at particular facilities. However, the full extent of responsibility for the systematic exploitation and deaths remained difficult to establish through legal proceedings limited by evidence standards and the deaths of many perpetrators before trials could occur. Survivor accounts provided crucial testimony about conditions that documentary records alone could not fully convey. Personal narratives describe the daily reality of forced labor, the arbitrary violence, the inadequate food, and the deaths of fellow prisoners. These testimonies created a human dimension to statistics about casualties, transforming abstract numbers into individual stories of suffering. Survivors also provided information about specific guards, administrators, and policies that documentary records might not mention. In the end, their accounts became essential components of historical understanding and legal proceedings, attempting to establish accountability for wartime crimes. Over time, compensation efforts for survivors and victims' families proceeded unevenly, with some receiving payments decades after liberation, while others received nothing. Legal frameworks for compensation evolved gradually through the post-war period as nations addressed questions about responsibility and appropriate remedies. Some survivors filed claims successfully, receiving monetary payments, acknowledging their suffering. By contrast, others lacked documentation, proving their forced labor at specific sites or could not navigate complex legal processes. Ultimately, the compensation programs represented attempts at justice but could never fully address the scope of harm inflicted or adequately compensate for years of brutal exploitation and the deaths of thousands who never survived to seek compensation. After the war, long-term outcomes varied significantly between different facility types and locations. Many sites were repurposed for civilian or military uses by occupying powers. Some underground factories became storage facilities. Similarly, former command centers housed occupation administration temporarily. For example, the West Wall bunkers received various civilian adaptations including storage, emergency shelters, and even residential conversions in some cases. Repurposing prevented abandonment while avoiding the expense of demolition for structures built to withstand sustained assault. In other cases, installations were sealed rather than demolished, with entrances filled or blocked to prevent access, while leaving structures intact beneath ground. Sealing provided an economical solution for facilities too expensive to completely remove, but too dangerous or sensitive to leave accessible. Thus, sealed sites contained unexploded ordnance or structural hazards, making them dangerous for casual visitors. Meanwhile, others contained materials or equipment considered sensitive by occupation authorities. In the end, sealing prevented unauthorized access while deferring decisions about ultimate disposition until resources became available for more permanent solutions. Finally, dismantled sites underwent complete removal when strategic, safety, or political considerations made preservation unacceptable. Symbolic installations like Wewelsburg's modified North Tower saw partial demolition of features most associated with SS ideology. Urban facilities integrated into existing buildings received removal of hidden fortifications and special equipment. Some high-profile installations underwent demolition specifically to prevent them from becoming monuments to the defeated regime. Ultimately, the dismantling served both practical purposes and symbolic functions, erasing physical reminders of structures that had served the regime's most objectionable purposes. In fact, preservation efforts converted some facilities into historical education centers, teaching visitors about wartime events and the regime's operations. Museums developed at former command centers and concentration camps, combining preserved structures with exhibitions explaining historical context. These museums served educational purposes, teaching younger generations about this historical period while memorializing victims who died during construction or in regime violence. In practice, preservation balanced competing considerations, maintaining structural authenticity while ensuring visitor safety, providing historical education without glorifying the regime, and acknowledging victims without sensationalizing suffering. Wewelsburg Castle exemplifies preservation approaches combining partial restoration, museum development, and historical documentation. The facility now houses exhibitions about SS ideology, the castle's wartime modifications, forced labor used during construction, and the broader historical context. In the end, preservation maintained enough original structure, allowing visitors to understand the site's historical function while removing or contextualizing symbolic elements to prevent the site from serving neo-Nazi purposes. The museum demonstrates approaches to controversial historical sites by emphasizing education over preservation of every structural element. Steel installation needed understanding of structural engineering that determined proper placement for maximum strength against explosive forces. Other sites remained restricted due to structural hazards presenting genuine safety risks that preservation could not economically address. Collapsed tunnels, unstable concrete, unexploded ordnance, and environmental contamination made some former facilities too dangerous for public access. As a result, access restrictions protected visitors while avoiding costs of complete cleanup or restoration. These restricted sites contributed to historical understanding through documentation rather than physical visitation, with photographs, architectural records, and scholarly analysis substituting for direct public access to physical structures. Modern relevance extends beyond historical interest into practical influences on later developments in multiple fields. Bunker research influenced emergency planning protocols in nations developing civil defense systems during the Cold War. For example, German engineering solutions to specific problems, ventilation in sealed spaces, independent power systems, underground construction techniques, informed later military and civilian projects requiring similar capabilities. Analysis of protection effectiveness against different weapon types contributed to understanding needed for designing survivable structures in the nuclear age. Underground infrastructure design benefited from lessons about what worked well and what problems emerged from German wartime experience. Later underground facilities avoided some mistakes apparent in hastily built wartime installations. Construction techniques improved through understanding of challenges German engineers faced. In the end, the wartime experience provided practical knowledge about underground logistics, environmental control, and structural requirements, informing post-war construction of subway systems, underground parking facilities, and other civilian infrastructure projects requiring similar engineering solutions to challenges first addressed in wartime military construction. On the other hand, national security architecture incorporated relevant lessons while adapting to changed circumstances. Cold War bunkers reflected understanding gained from studying German facilities. Command center designs showed the influence of analyzed German approaches to protection and communication. However, nuclear weapons fundamentally changed protection requirements, making some wartime solutions obsolete while emphasizing underground depth and hardening beyond what conventional weapons demanded. The influence, therefore, mixed direct borrowing of proven solutions with adaptation addressing new threats that wartime German installations never needed to consider. Specific technical solutions developed for German wartime facilities found direct application in later construction projects worldwide. Blast door designs informed post-war protective construction. Ventilation systems for sealed spaces adapted German engineering solutions. Independent power generation configurations borrowed from successful German installations. Meanwhile, communication system redundancy reflected lessons about maintaining contact despite infrastructure damage. Water purification for isolated facilities drew on German experience. Eventually, these technical borrowings represented transfer of engineering knowledge separate from political associations with the regime that developed the original solutions. Paul Williams argues convincingly that modern preservation efforts must emphasize worker suffering over engineering achievement, deliberately refusing to separate technical skill from moral cost. This approach ensures visitors understand these sites fundamentally as places of horror built through systematic human exploitation, not as monuments to German engineering prowess that might be admired independent of their terrible human cost. Today, architectural preservation debates continue regarding how to maintain historical sites while avoiding glorification of the regime that built them. Some facilities became museums with explicit educational missions explaining historical context. By contrast, others underwent demolition, removing structures too closely associated with regime ideology. Still others remain restricted with limited access for researchers but not the general public. These choices reflect ongoing tensions between historical preservation, educational objectives, sensitivity to victims, and concerns about neo-Nazi misuse of sites for political purposes. At the same time, educational programs developed at preserved sites attempt to convey complex historical lessons to visitors with varying levels of background knowledge. Exhibitions must explain military context without glorifying warfare. They must describe technological achievements without ignoring human costs. They must acknowledge victims without sensationalizing suffering. They must present facts objectively while clearly condemning crimes. Achieving these balanced educational goals requires careful curation, extensive historical research, and ongoing refinement based on visitor responses and scholarly feedback. In fact, tourism at former facilities raises ethical questions about appropriate treatment of sites associated with historical atrocities. Some argue that any tourism commercializes tragic history inappropriately. On the other hand, others argue that controlled tourism serves educational purposes while generating revenue supporting preservation and historical research. In particular, facilities converted to restaurants or hotels face particular criticism for appearing to profit from associations with historic crimes. These tensions create ongoing debates about proper treatment of controversial historical sites. Academic research continues examining these facilities from multiple disciplinary perspectives, including military history, architectural history, engineering analysis, and ethical frameworks evaluating construction methods and human costs. Waterproofing underground facilities needed multiple protection layers preventing moisture that could damage equipment and create unhealthy conditions. Related topics extending from this examination include hidden wartime infrastructure across Europe beyond German facilities. Britain constructed substantial underground facilities, including war rooms and production sites. The Soviet Union built protected command centers and evacuation facilities. France developed resistance networks using hidden installations. Examination of these parallel systems reveals common problems and diverse solutions different nations developed for similar challenges. In the end, underground command networks became standard features of military infrastructure worldwide, with wartime German facilities representing one example within a broader pattern rather than a unique phenomenon. The protected facilities formed a system reflecting the regime's combination of technological capability, brutal exploitation, strategic desperation, and fundamental disconnect from reality. Engineering accomplishments demonstrated resource-intensive construction under difficult wartime conditions. Protected facilities continued functioning despite sustained bombing that devastated surface infrastructure. Underground factories maintained production after above-ground alternatives were destroyed. In addition, communication systems adapted to loss of individual facilities through redundancy. The technical achievements showed what systematic engineering effort could accomplish given sufficient resources and disregard for human costs. However, these accomplishments came through brutal exploitation of forced labor treated as disposable resources. Thousands died building facilities protecting leadership that enslaved them. Concentration camp prisoners worked in conditions designed to extract maximum effort regardless of survival. Ultimately, this cruelty tainted every achievement, making the technical capability evidence of moral bankruptcy rather than admirable engineering. The facilities stood as monuments to systematic dehumanization where human lives counted for nothing in calculations about construction schedules and resource allocation. During this period, strategic desperation drove late-war construction when Germany clearly faced military defeat. Resources flowed to protective facilities while frontline forces lacked adequate supplies. Underground factories diverted materials for more effective uses. Leadership protection took precedence over population welfare. These choices reflected recognition that the war was lost combined with refusal to accept inevitable outcomes. These facilities allowed leadership to continue functioning slightly longer but could not change ultimate outcomes. Therefore, the investment represented wasted resources that might have served productive purposes if leadership had faced reality rather than retreating into protected isolation. By this point, fundamental disconnect from reality characterized decision-making increasingly divorced from actual conditions. Thick concrete walls keeping bombs out also kept uncomfortable truths out. Leadership isolated in bunkers received filtered information matching their preconceptions rather than reflecting battlefield realities. In the end, orders were issued to non-existent armies based on situation maps showing desired positions rather than actual force dispositions. The physical isolation enabled psychological denial, allowing delusions to persist beyond any rational assessment. These protected facilities therefore contributed to prolonging rather than resolving the regime's final crisis. J. E. Kaufman's study of German defensive architecture captures this fundamental flaw. The elaborate bunkers successfully protected individual leaders from immediate physical harm, but offered no pathway to avoiding strategic defeat. The fortifications succeeded tactically while failing strategically. They accomplished everything except what actually mattered. Eventually, the legacy combines technical lessons applicable to legitimate defensive purposes with moral warnings about human costs hidden behind engineering accomplishments. Future generations studying these facilities must recognize both aspects. Technical knowledge about protection, underground construction, and hardened facilities serves useful purposes when applied ethically. However, this knowledge came partly through systematic exploitation that cannot be separated from the engineering achievements when evaluating this historical episode honestly. The ruins remain as monuments to all these elements and as warnings about the costs of absolute power exercised without moral restraint. They document a historical period when technological capability combined with ideological extremism produced structures built through human suffering to protect a regime causing suffering on an unprecedented scale. Ultimately, understanding these facilities requires acknowledging both what they accomplished technically and what they revealed morally about the system that created them. These facilities represent only one aspect of the regime's final years. The individuals who occupied these bunkers made decisions that shaped the war's conclusion. For a deeper examination of leadership dynamics during this period, see this video next.